Hello everyone, today I'm just doing a short video on how to assemble a USB valve. This is a project that I came across on GitHub. I'll credit the original creator in the description below with a link to the GitHub page. The purpose of this video is to show exactly how you have to assemble these components in order to get this functional, and I'm going to make it so simple that anybody, whether they're a novice or a professional, when it comes to soldering, will be able to follow the guide and make one of these at home. So first thing you want to do is line up the Raspberry Pi Pico with the printed circuit board for the USB valve and use a piece of Kapton tape to hold it in place. Once the Raspberry Pi Pico is taped into place, we can go ahead and put some flux on all the pins that need to be soldered. There are a total of 11 pins on this that need to be soldered, and that includes the debug pins at the bottom of the board. Just to be sure that everyone knows where to solder this, I'm going to throw up a picture on screen right now. You can pause the video. The blue points in that picture are where you need to solder the Raspberry Pi Pico to the USB valve PCB. Alright, now that you know where to solder, let's get these pins soldered. Alright, so right here you see me adjusting the circuit board. I want to make sure that this is straight because once you solder one point, that's it. You're not going to be able to move it. What I like to solder first are the 3 debug pins at the bottom of the board. After the debug pins are soldered, I like to go to the right side of the board and solder the 3rd pin up from the bottom. Then I move to the left side of the board and I solder the first 2 pins on the bottom left corner. From there I move to the top right hand side where you have to solder a total of 3 pins. It starts at the very first pin, but you skip a pin, and then there's a second pin, and then you skip another pin, and there's a 3rd pin. Now you're going to see me just go back to previous pins that I've already soldered. I'm adding a little more solder to touch up on these and make a stronger joint. The pins on the left hand side at the bottom of the board need more solder. I had to switch to my left hand to do this. I'm right-handed and this is difficult for me. Now we're going to solder the final 2 pins at the top on the left hand side. So these pins are pins 6 and 7 from the top. I covered up pin 7, so what I'm going to have to do here is remove the Kapton tape and solder this afterwards. But since all the other pins are already soldered in place, we don't need the Kapton tape anymore. The Raspberry Pi Pico is not going to move. Alright, so let's get that final pin. We're going to add some flux so we can get the solder to flow easily. And now we're going to add some solder. And this is the final pin we need to do. Alright, so what I'm going to do here is do some touch up. What I like to do when I'm soldering is to go back and inspect all my joints, and if there's anything that I don't like, I'll quickly fix it. This is a lot easier to do before this thing's totally assembled. Alright, so now we're going to get the OLED display attached, but before we do that, we need to put a piece of Kapton tape on the back of this. The reason for that is this prevents it from touching and shorting out on the Raspberry Pi Pico when you solder it to the board. When you're done, this is what it should look like. Now we can go ahead and get the OLED display soldered to the board. So this just fits right into these 4 holes here. Make sure the OLED display is facing upward so it doesn't block the section of the circuit board where the USB port needs to be soldered to. Now I'm going to add some flux to those 4 pins so that we can get the solder to flow to them. Now what I like to do is take the solder and add it to my soldering iron. And the reason for this is because I need to use my left hand to make sure that the screen is flush and square with the printed circuit board. And then what I'm going to do is I'm just going to solder the very first pin. And then after I solder the first pin and we check to make sure that it's aligned properly, I will solder the remaining 3. Alright, so let's do a quick inspection here, and that OLED screen looks pretty straight. So we can go ahead and solder the remaining 3 pins. Once the OLED screen is soldered in place, there's 2 pads that are above it. They're called ground 2 and VCC2. These pads need to be joined together with a blob of solder. So as you see here, I'm adding some flux so I can get the solder to attach to them. If you're using the same style OLED that I'm using in this video, then you want to add a solder blob to ground 2 and VCC2. If you have a different OLED and the ground and VCC pins are swapped, then you need to add them to VCC1 and ground pin 1. Now that you know which pads you need to bridge together with a blob of solder, I'm going to go ahead and move to my microscope camera so that you can see me do this. So these are the pads I was referring to. It's VCC2 and ground 2. You need to bridge the pads with some solder. The easiest way to do this is put some flux on the board and then get a nice big blob of solder on the soldering iron and slowly move it between the pads and away, and it'll bridge them, just as you see in this video. Some of the OLEDs that you can buy online have the ground and VCC pins swapped, so if that's the case, you're going to have to use the pins that are above these that are number 1 on the printed circuit board. I don't show that in this video because you can't bridge both of them and get this to work. That being said, if you're using the same type of OLED screen that I show in the video and the ground pin is number 1 and the VCC pin is number 2, then you just follow this tutorial. If those are swapped, use the other set of pads on the printed circuit board. Here I'm just checking the 4 pins that go to the OLED to make sure that they're soldered properly. And then what I'm going to do is I'm going to grab some Q-tips and some isopropyl alcohol, and I'm going to clean this flux off the board. Alright, so the final component we need to solder to the board is the USB port. There are two pins on the bottom of the port which align with two holes in the board. And I'm showing you the pins right here. And then I'm showing you the holes on the board that those go into. Now the holes on the board are a bit larger than the pins on the USB port, so there is some wiggle room. But it'll at least get you lined up mostly so that you can't mess this up. Alright, so here I'm going to add some flux, and what I like to do is there's two large ground pins on the side of the port. I like to solder those in place first, and then the 4 pins in the back I solder after, which I will show you guys that soldering process under the microscope so that you can see it. So what I recommend doing here is exactly what I do in the video. Because you need a hand to hold the USB port in place, add a bunch of solder to your soldering iron and then use your left hand to hold the USB port in place and bring the soldering iron over and drop that solder on the first ground tab, and that'll hold it in place so that you can do the other one. Now I'm going to flip the board around and I'm going to get that other ground tab soldered in place. And here I'm just adding a little more solder to these ground tabs. You want to make sure you have enough solder on these joints so that they're strong. These ground tabs are what will take the force when you're plugging a device into this port, so if you don't have enough solder, this is likely where you'll end up having a failure. Alright, so here I'm just going to solder the pins. Whoops, looks like I'm moving the printed circuit board. Yeah, sometimes it's best just to tape this down, so I didn't do it for this video, but that's what I would recommend. So you want to come in here and you just want to get enough solder on each one of these pins so that they're covered and they're adhered to the board. Sometimes what I find is that some of these pins won't take the solder. If that's the case, add a bunch of flux to it. The flux makes it flow and I'll get it. Sometimes tin has a coating on it that for some reason repels solder until that flux gets in there and cleans it up. And there we go. All 4 pins are soldered in place. So I'm going to go ahead and grab a Q-tip and some isopropyl alcohol, and we're going to clean this flux up. Alright, so that should be the end of the video. You now have all the components soldered in place for the USB valve to work. All you gotta do is load the firmware using a micro USB to USB cable and your computer. The firmware can be found on the GitHub page. If you run into any issues or have any questions, feel free to stop over on my website at tzerf.com and make a post. And with that said, I'll see you guys in another video, and good luck with this guide. Just wanted to mention before I go, if you're looking for the printed circuit board, I purchased mine on eBay, so I would recommend looking there. You can also find the OLED and USB port on eBay as well. The Raspberry Pi Pico can be purchased at Amazon. See ya.